Okay, good afternoon. Today we're gonna present about embedded system application, which is end of chapter PIC programming in C.
Okay, so our group members is me, Zekius Durang Jarangku, 07DM23F1010, and Shukri Binang Jeffrey, 07DM23F1004.
Okay, for the introduction, this project focus on designing a simple embedded system using a PIC microcontroller to control 3 LED. The system creates a back and forth running light effect, which is commonly used in status indicators, security system, and scanning display. The project is developed using MPLAB, IDE, and C programming, applying basic concepts such as loops, conditional statement, port configuration, and delay function. Through this project, we aim to understand how microcontroller execute sequential output, control and timing operation in real application.
Okay, so for the problem statement, many systems requires a back and forth LED lighting pattern for visual indication. To create this effect, a PIC microcontroller is programmed to control LEDs connected to RC0, RC1, and RC2. The system lights up the LEDs in a forward direction, that is from RC0 to RC1 and lastly to RC2 for 5 times, and then in reverse direction another 5 times. The sequence continue repeatedly with a zero point 0.5 second delay between each LED change using an if/else structure to switch direction automatically.
For the code structure overview, the program is written in C language using MPLAB IDE. Key elements in the code include CXH, which is access PIC register, and commands. Next, we must define XTAL underscore frag 8 million to define clock speed for delay accuracy. And next, we must contain main for contain the main control program. And lastly, we must contain delay MS, which is to create a half-second pause for LED transition.
Okay, so next is data types and operators. In this project, data types are used to store and control values for loops and LED direction. The variable int is used as a counter to repeat the LED sequence, while int forward is used to control the direction of the running light, forward or reverse. So first we have binary PORTC. This is to turn on LED connected to RC2. Then second one we have hexadecimal. This is to have the same effect and either from the binary form. And then third one is decimal INTI. This is to assign a starting value for counting loop. And then the fourth one is talking about operators are symbols that perform actions on variables, such as the example that have been given there.
Next, delay function and XTAL frag. The delay function controls the timing between LED changes. Next, delay underscore ms 500 creates a 0.5 second delay between each LED lighting. XTAL underscore frag define the crystal oscillator frequency of the PIC. Next, in this project, XTAL underscore frag equal to 8 million, which is 8 megahertz. Next, it allows the compiler to calculate accurate delay timing. Without xtal_frag, the delay function will not work correctly. And the last, both delay and frequency definition ensure consistent LED blinking speed.
Okay, for the next one is talking about input and output configuration. So before running the program, pins must be configured as input or output. 3C register is used to set the pin direction. Then 3C equals to binary number sets RC0, RC1 and RC2 as outputs, others as an inputs. Then output pins for RC0 and to RC2 are connected to the LEDs, and input pins RC3 to RC7 remains unused in this project. Port C register controls the LED on or off states, and then port C binary number turns on LED at RC0 and also RC2. Lastly, proper configuration ensures each LED lights up correctly during operation. The picture above is the example of this input and output configuration.
Next, for the conditional statement. Conditional statement decide the LED running direction. The variable forward controls the sequence 1 equals forward, 0 equals to reverse. If forward equals 1, LEDs run RCO to RC1 and RC2, which is in forward. Else, LEDs run RC2, RC1, RCO, which is reverse. After 5 loops, forward value changes to reverse the direction. This creates the continuous back and forth LED pattern. The logic repeats endlessly inside the while loop.
So, in conclusion, this project successfully demonstrates the basic principles of PIC microcontroller programming. We use C language in MPLAB IDE to control three LEDs and create a continuous back and forth running light effect. The program applied key programming concepts such as loops, conditional statements, and delay function, which allow the LED to operate in both forward and reverse direction. Through this project, we gain a better understanding of how software logic interacts with hardware components in an embedded system. Overall, this project serves as a good foundation for developing more advanced automation and control application in the future. That's all from us. Thank you.